And on track one, we have Jon Glass from ESO, who are a company who also work in a company that does good things. Mm-hmm. And he's going to be talking about something that sounds quite fascinating, cache-driven testing.
So could be fun.
Over to you, Jon.
Great, thanks very much. So my name's Jon Glass. I work at ESO as a development manager. I still enjoy coding. I still make a lot of time to code as part of my job. And I guess the theme for today is around some work that we've been doing within projects that I'm involved with over the last year or so. And it's kind of a theme for me as well. You know, I think probably the biggest light bulb moment for me in my time coding was when I really understood what test-driven development meant. Building out tests first, I guess, and then fixing them. And I think behavior-driven development is a kind of evolution of that, where we kind of extend that to say, what am I testing? Am I going to test something that is a kind of internal behavior of an application? Or am I going to test something that's actually an externally observable behavior of an application? BDD is really, really powerful. I love it. But it can introduce some complexity around how to test, because if you're testing kind of larger swathes of your application stack, it can be quite hard to figure out a good way to do the testing. So I guess the theme of this talk is kind of zooming out from what we do day to day to some of the things that will facilitate what we do day to day. And one of the things that I enjoy about my job at the moment is kind of zooming out again from that and thinking about kind of how it supports the mission of the company in terms of what we do. So I guess in a lot of things that are more physical and more visible, in order to build a machine, you have to build another machine first. Wind turbines, I kind of love wind turbines. Some people like them, some people don't. But I love this guy in the nacelle here. Like, his job is to do these bolts up, to hold the blades onto the nacelle. The thing's going to spin around, generate power. And there are probably times that he forgets that he's 120 meters up in the air, and that the thing he's bolting on is hanging from a crane. His job is a small thing, but it's enabled by a whole bunch of things that are around him and helping him to do that. And somebody had to build those. As software engineers, we're responsible for building those things as well as for using them. So I guess this is kind of an observation of mine around continuous integration and some of the problems that it can give us. So what we'd like to do is we'd like to test the whole application on every development branch. So we know before we merge that everything works. Test runs should be fast, they should have high sensitivity, and they should have high specificity. That means they should have high false positive rate, or very low false positive rates, and they should have very low false negative rates. If the build goes green, we know that there's a problem. And probably more perniciously, I suppose, if the build goes red, we know that there's a problem. Flaky tests are a huge problem with sort of end-to-end testing, where you go, oh yeah, that one always fails, just merge it. Oops, what have I done there? Yeah, so hitting external services is problematic. If I need external resources, then I have to stand them up in the environment. And if I want to run branch builds, I want to run builds in parallel, I need to really have minimal external dependencies. Even with kind of containerization, standing up a whole environment for every build, it can be complex, it can be slow, it can be expensive just in terms of compute time. So typically there's a bit of a compromise. What you run in kind of CI and what you run after you merge. And then when we find defects after merges, we kind of have to ask, well, how could we engineer an earlier warning? So I guess to that topic of selectivity and specificity of tests, people that have written tests, hopefully a lot of you, will know that there are different ways to do this. So unit testing is kind of fast and detailed. I can test an individual service, or I can test a couple of services or a few services, but it's not typically behavior-driven. And so it's pretty brittle when we come to refactor. If I change internal interface boundaries that unit tests rely on, I typically have to rewrite all of my tests. And that's kind of a shame, because tests represent knowledge that maybe passes on, bugs that somebody found while they were writing something, are not necessarily easy to find again later. Mocking is kind of typically the answer where you've got external services and you don't want to be dependent on them. So if we create mocks at kind of interface boundaries, then we can end-to-end test the application without the external dependencies. But mocks themselves are brittle. Brittleness is a theme, but toughness is the opposite of brittleness. And the definition of toughness is kind of quite informative. It's the ability of a material to deform under load, under stress, without breaking. So it's basically like how much damage can your test take before they fall apart. And then in terms of brittleness, breaking, it says here, breaking is often accompanied by a snapping sound. Now, anybody that's ever maintained, a kind of complex set of mocks has probably heard that snapping sound as their kind of carefully maintained Ming vase of mocks just falls over because, the particular path or the particular order of things is not being respected by a change to the internal code. So toughness is something we want to achieve. End-to-end testing kind of does that, but it has the drawbacks that we talked about, which is that it can be hard to set up, can be slow to run, and it can be unreliable. If I'm doing things like Selenium browser automation testing, I can have quite a high kind of false negative rate. So cache-driven is a kind of hybrid approach. We work in two different modes. The first mode is in local development, and I typically I call it harvesting. So harvesting is the idea that I'm using a local mode where I've got all of these external services to harvest and kind of automatically create the things that I would otherwise have to manually lay out in mocks in my kind of mocking framework. And in that kind of harvest equals true mode, I'm connected to the databases. I have a read-through cache, and that cache is serialized into my source code. And the mock is therefore kind of self-generating and self-healing. So if I run my tests, if I've changed something, even as simple as a new line in a SQL query, or changing the name of a parameter or something, that can break a mock that I've carefully set up. But actually, what I would see in the read-through cache is that query would just change. And then when I look at the change in my source code, I'd see, well, my cache has changed slightly, but actually that hasn't affected the behavior. On my CI pipelines, I set my harvest to false. So harvest false means I'm going to have no external dependencies. It's not a read-through cache anymore, it's a read-only cache, and the cache is stored in the source code. So the mock service mimics the external dependency precisely, provided the code does all the things that it did when it was harvesting. And so those tests can run fine on my CI pipeline, and within reason they're pretty tough with respect to internal changes in code. So I guess I was just going to say, this is the example I've shown here is for a database, but we do the same thing with APIs, with file stores, any external dependency you can think of. Actually, database is probably the hardest one. APIs, a JSON API is trivially serializable, obviously in terms of requests and responses. So I wanted to show you a demo. I wanted to show you something a little bit more interesting, I suppose, than just a database and an API. So this is a tool that we use internally. We've picked up a couple of applications by acquisition, and those applications have a lot of legacy code in them. And one of the things that we've picked up is a lot of VB script code. It's kind of expensive, time-consuming, and error-prone to rewrite that and to port it into a new language. So we've written a tool to help us do that. We call it AspCop because it started out life as a static analyzer for VB script. And then once we got good at kind of parsing VB script, we kind of expanded it and found that this transpilation idea was actually workable. And it kind of has two pieces. So the one piece is the transpiler, which takes ASP code and it turns it into C# code. And the second piece is the runtime, which you can see the kind of light box on the right-hand side there, which the C# code kind of talks to. It emulates the runtime that the ASP code was expecting, and it interfaces out to the .NET runtime. So there's quite a lot going on in there, but the thing that we want to validate, the kind of invariant, if you like, here, is that this legacy code, if I convert it to C#, it should serve exactly the same page as it did before the conversion. So in that example there, I've got my browser client. It's hitting the classic ASP site, the legacy site, and it's going to serve an HTML file back to me. What I want to do is I want to run through that transpilation process, spin that transpile code up in the runtime, and I want it to give me exactly the same HTML file. So let's see how we can do that. So what I've got here is a set of test cases which are called the transpiler test cases. And there's two important tests here that I want to show you. The first one says test cases converted should convert to C# correctly. So my test cases should transpile. And the second test case says transpile pages should serve same content as IIS. So to give an example of this, here is a classic ASP file. Some of you may be unfortunate enough to be familiar with this and understand it. Many of you will be lucky enough not to. It's quite familiar if you know ASP.NET. It's the forerunner of ASP.NET. So it kind of has a good history behind it, but it's not really great for running production applications today. So this page, I could put this on a site, and I could get the HTML for that page by just serving it off the site. And indeed, that's kind of what I've done here. So what we store in our test project is the ASP file, the C# file which was generated by the transpiler, and if you look here at this, you can see I've got my HTML body. It's kind of doing the same thing as the ASP file here, slightly less elegantly, but I'm basically just writing HTML response of this kind of A, B, C, D, X. The tool has done that, it's generated that automatically. The other thing that I need is my expectation. So in terms of my expectation in the test, it's the HTML document. So I've got this in here, and what I can do is I can run my tests here, and these tests run, once they finish building, they run pretty quickly. So there we go, that's done. That's all my test cases run, because there's no external dependencies, so it's super fast. What I've got though is I've got a problem. So I found a bug, and I'm going to take you through fixing it. So what I brought in here is a new file. It should be popping up here. Just check that I've got this. Oh, yeah, there it is. Cool. Right. So this is another ASP file, and this demonstrates a bug that we found a little while ago, and it's in the date add function. So date add, as you probably expect, is going to add, in this case, 7 hours to my test date, my source date. I'm starting with 8:29, so I'm expecting like 3:29 p.m., I guess, as my output. But what I've also discovered is that if I add a fractional number of hours, it's not going to add that extra rounded number. It's just going to add 7. So the behavior of this function in classic ASP, in the original code, in the original runtime, is that it truncates this 7.8 down to a 7, and we found that actually our code doesn't do that. So our runtime doesn't do that. So I'm going to run the test and just walk you through what this does. So in the first case here, the first thing it's going to do is it's going to try and transpile it. And what this one will say is, well, I expected nothing because that C# file wasn't there a second ago, but I got 53 lines of C# code. That's great. So the C# is now here, it's generated. I will run the test again, and this time that first one should succeed. So I've got this C# file, that's going to get checked in to source control, and that's my kind of reference between the two. The next stage is then my should serve same as IS. Now this one's failing. It's saying expected 0 string length, but was an HTML file. So the reason it's saying 0 string length is because I don't have the HTML file. The HTML file doesn't exist. I don't have any means of kind of knowing directly what the output should be. So I could handwrite it, but actually what I can do is I can use this kind of harvesting mode. I'm going to go up to the top of my test case, test class here. I'm going to change my harvest flag to true. Now what's going to happen is, based on this harvest file, this test does one of two things. So if harvest is false, it's just going to load the HTML file from the source code. That's the thing that's checked in, no external dependencies, and that's what you saw before when all those tests were running and going green. If harvest is true, then I'm going to hit an internal IIS server that I've set up. So I've just configured port 7979 to map to this folder that has all of my test files in. So if I hit slash, what is mine, date value, date add fractional.asp, then I'm going to get back from IIS my reference. It's going to tell me this is what I'm serving to you, and therefore this is what you should be serving from your emulator. So if I run this now, I will get a different result from the test, because in this case, the new file will appear. So the new file has appeared. That's the HTML. Again, I'm going to check this into source control. This is the expectation, and you can see here that 8:29 has gone to 3:29 p.m. in both cases. So this is what ASP is doing, but you can also see my test has failed. So the reason it's failed is because the expectation is 3:29. That's what classic ASP has given me. But the actual is I've actually added like 7.8 hours to my time, which is wrong. So let's go back in here. Let's figure out what went wrong. So my ASP.dateAdd has failed here to do the right thing. And the reason it's failed is because when I look at the code here, I can see, well, actually, I've kind of made a mistake here. I've truncated the number for years and quarters and months, but what I should have done is truncated it for all of these values. So I'm going to do this in just a slightly quicker way here. If I just extract that one, and I call this whole number, and if I bracket cast to int, I can now remove these redundant bracket casts. So what I've got here now is every case where I do this addition, I'm going to truncate the value that was passed in, and I'm going to add a whole number of years, weeks, hours, seconds, whatever it is that I need to add. So I save this now, and run these tests again. It doesn't need to retranspile because the source code is the same. I've just changed the runtime, so the runtime is now fixed. And the runtime is now giving me green. I'm passing because both my transpiled file and my original file are giving me the correct answer. And then just to kind of show you what's happening in source code here, I'll go through these in order. Oh, there's one last thing I have to do actually. This is a good point. So when I run these tests, I've still got one that's failing. And the one that's failing is, again, just part of the pattern here, having a test that just says harvest should be false when checked in. So I want to make sure that I set that harvest flag to false, because otherwise I'm going to get weird behavior on my build server. It's going to be trying to hit port 7979. It's going to be really slow. You know, it's not good. So just to make sure that I'm fully green here, I can now close this, set this back to false. That's not going to build. Set this back to false, run it again, and this time all of my tests should go green. And because harvest is false now, that means that I don't have any external dependency on my IIS server being present. So I'm going to go back into source tree here. The only changes I've got now are my ASP file, I just changed that. So that's the thing I'm adding, is the ASP file that demonstrates the bug. This ASP.cs was generated. It's not strictly necessary, but it's useful because it means that when I'm troubleshooting issues, I can look at the generated C# file, and I can actually see kind of where the problem maybe originated from. And then this is the generated HTML, which tells me what my expectation for the test is, and I'm going to check those in. And finally, of course, the fix. So if I commit all of those, I've done a kind of TDD approach there of sort of finding the bug, proving that the bug exists, creating a test that goes red. I've then fixed the bug, and I'm committing the fix in here, and that's my resolution. So I guess kind of zooming back out again here, this is kind of, I'm the guy putting the bolts into the hub to put the blades onto the fan. I'm doing quite a small job here. But I've made the job easy, and I've made the job reliable, and I've made it behavior driven, and I've made it fast to run across CI, across many branches. It's very reliable. It's got very high specificity and sensitivity because it's all in memory. There are loads of really good things going on here, but they've happened because we've invested time in building a test framework that has then helped to make everyone in the team more productive. And I guess that's kind of what I wanted to share with you. Thanks very much.
Okay, thank you very much, John. And that was the last talk of the day. And I'm pleased to report we've just checked the numbers, and we are bigger than we were in last year. So.